All right, so we've already learned about our alkanes, our alkenes, and our alkynes. So those are our carbons and hydrogens, but we can have other elements on our hydrocarbon chains. And so we call these functional groups. They often add function to the molecule, hence the name. So the first type of functional groups are alcohols. Alcohols have a carbon and then an OH group, right? An oxygen and then a hydrogen. And then, of course, this carbon has 3 other bonds. That way, the carbon has 4 bonds total. So if you have 2 carbons and then an OH, that's ethanol. That's the kind of alcohol that you drink to get drunk, and that's why, it's alcohols, is just common language. But generally, when you're talking about common language, you're just referring to ethanol, whereas in chemistry, alcohol is anything with an OH group. For example, if you just have 1 carbon and an OH, that's methanol. If you drink that, you're going to go blind. If you have 3 carbons and then off the center carbon, there's an OH, that's isopropanol, often used to clean electronics or maybe even nails. The next one is a subtype of functional group. So there's carbonyls. And so there's a whole bunch of different carbonyls. So it's not good enough to just call something a carbonyl. You have to identify what type of carbonyl it is. So carbonyls, they all have the same motif. And that motif is that we have a carbon that's doubly bound to an oxygen, right? So that's where that carbonyl part comes from. But there's many different kinds. So the first kind is an aldehyde. In an aldehyde, again, we have a carbon doubly bound to an oxygen, but then on the one end, we have an hydrogen, right? So aldehydes, since there's a hydrogen on one end, they always show up at the ends of molecules, right? That could be the beginning end or the, end. So for example, if you have 5 carbons long, that's an aldehyde on the left side, and then that's an aldehyde on the right side, right? They show up on one of the ends. Another common aldehyde is formaldehyde, which is the one that has 2 hydrogens on either end. Next type of carbonyl is a ketone. Ketone and aldehydes are really similar, except instead of having that hydrogen on the end, in ketones, you have carbons on both ends, right? So that's acetone right there, used to clean nails and used to clean glassware in chemical labs. But, there's another ketone right there, or we could even have 2 ketones in one molecule. But you see on both ends of our ketone, we have carbons coming off of them. Next type of carbonyl will be a carboxylic acid. And a carboxylic acid looks like an aldehyde plus an alcohol, or a carbonyl plus an alcohol. But it behaves completely different than other types of carbonyls, and it behaves completely different than alcohols. So this is a distinct functional group. And the motif here we have, right, is a carbonyl, and then on the other end we have an OH. So that's a carboxylic acid. You cannot call that an alcohol. It is not an alcohol. It's a carboxylic acid. So there's an example of a carboxylic acid right there. You could put it in, some kind of ring structure, maybe like a cyclohexane, and then you have carboxylic acid coming off the end. The most common carboxylic acid is right there. That's acetic acid, otherwise known as vinegar, right? So vinegar is mostly water with some acetic acid, and that's what gives it that vinegary taste. Next up, we have amides, which are a carbonyl. And then we have an amine group, so a nitrogen with 2 other things attached to it. They could be 2 H's, or they could be 2 carbons or something else, right? But either way, they make up amides. So they could have, some more R groups, right? Something like, so just some carbon chains, right? But either way, carbonyl and then a nitrogen, that makes an amide. After that, we've got esters. Esters are similar to carboxylic acids, but there's an important difference. Again, we have a carbonyl, we have an oxygen, except now instead of this oxygen being attached to a hydrogen, it's attached to something else, right? So it's usually some other carbon types of groups. So for example, something like that, right? That's a ester right there. You can see we have a carbonyl, and then we have an oxygen group, and then we have more carbons coming off of that oxygen group. Again, similar to carboxylic acid, it behaves very chemically different. Next up, we've got an ether. An ether is just an oxygen with two carbon-based groups on either side. So the most common ether is diethyl ether, right? There's two ethyl groups and then an oxygen in the middle. And ether, again, is just an oxygen with two carbons on either end, right? Same thing right here. That's THF, very common solvent. You can see we've got an oxygen and then two carbons, one on either end. Next up, we've got amines. Amines are nitrogens. So anytime you have a nitrogen, you have an amine, unless you have an amide. So for example, something like that, right? Remember that nitrogen has 3 bonds in a lone pair. We don't have to draw the lone pair, but you can if you want to. One of the most common amines is triethylamine. So there's that one right there. Amines are very common in fish, and it's what gives fish that fishy smell and taste. Next up, we've got haloalkanes or alkyl halides, whatever you want to call them. And here we just have some type of halogen. So for example, it's often written as X, where X can either be fluorine, chlorine, bromine, or iodine, right, or halogen. So if you see any of them, you've got a haloalkane. So there's one right there. There's one with bromine, right? And then there's one with iodine. So it just means you have some kind of halogen. And then the last functional group we're going to learn about are aromatic compounds or aromatics. In this case, we're just going to learn about one of them, and it's going to be this 6-membered ring with alternating double bonds. So it can look like that. It doesn't matter where you put the alternating double bonds. They actually are the same compound. These two are resonance structures of one another, so they're all equal to the same length. You can call this a benzene ring, or it is a benzene ring. As a substituent, it's sometimes called a benzyl or a phenyl group. There's unfortunately a bunch of different names at it. You can call it an aromatic, a benzene, a phenyl, a benzyl. It doesn't really matter to me. Again, all of these bonds are actually the same. So the real structure actually looks kind of like this, where all the bond lengths are the same, right? So one way to draw it is with these alternating double bonds. This circle also represents those alternating double bonds. So just a different way to draw it. So all you want to be able to do is be able to look at a molecule and pick out the individual functional groups. Do a practice problem or two and you should be able to get it. It's not too complex of a topic, just some memorization is required.